For the Chapter 1 test, it will be one piece of paper on both sides. The first part of it will be a matching section. One part of the matching will be on the types of numbers. Another part of matching will be on properties of exponents and some properties of real numbers. You'll have some matching and some true-false with those. Then you'll have to write some things into scientific notation and also take some things in scientific notation and write them as a number. You'll have to simplify some absolute value expressions, simplify exponents and radical expressions, like taking the square root of things or the fifth root of things. Then add, subtract, and multiply polynomials, which is also add, subtract, multiply algebraic expressions. You will have to factor expressions and then also simplify rational expressions, which means add, subtract, and multiply fractions. Pages 56 and 57 have a review in the book for you. If you want to do any of those problems on those 2 pages, you do some of the odds because those answers are in the back of the book, and then you can check to see if you're doing those things correctly, and that will help you get yourself prepared for the test. So, starting with number types, integers, remember, are those things like a -3, -2, -1, 0, 1, 2, 3, and so on and so forth. It does not include anything in between those numbers. It's just those that I've listed. Whole numbers are those that start at 0 and then go to 1, 2, 3, 4, and so on and so forth. It's the positive integers and 0. Rational numbers are those that can be written as an exponent in the form of a over b, where a and b are whole numbers, or actually integers. Natural numbers, they would be starting with 1, then 2, then 3, and so on and so forth. And with going back to the rational ones, things like 1/2, a -1/5, 2, those would be integers or rational numbers. And then irrational numbers would be the square root of 3, the square root of 5, those things that you can't write as a fraction. And then all of those together would get you the real numbers. Now with your properties of exponents, some things may be, if you have these 2 things, a to the m divided by a to the n, that is the same as saying a to the m minus n because you subtract them. If you have a to the m to the nth power, that is a to the m times n. There are other properties of exponents that you may need to know as well. Those are just 2 examples of them. Finally, in this slide, taking 25 million and writing it as a number in scientific notation, you need to take this number and first place the decimal point so that the number you have is between 1 and 10. And so 2.5 times 10 to the, and since we put the decimal point here, that means it has to be to the 7th power, because our decimal point has to move 7 places in order for us to get to 2.5. And with this one, it's 1.2 times 10 to the -4th. To write that as a number, we need to move the decimal point 4 places. So we'd get decimal point 3 zeros and then a 1, 2. Now with this, just simplifying this expression, 8 minus 15, which is a -7, and then the absolute value of a -7 is a +7. With our next example, it's the absolute value of -3 times a -4. Also, the absolute value of a -3 is 3 times a -4 is a -12. Anytime you have the absolute value, just remember it's the distance from 0. And you only take the absolute value of the things that are inside the absolute value symbol. Finally, with this one, you have the absolute value of x plus 5 if x is greater than or equal to a -5. You want to write an expression without the absolute value symbol anymore. So if you take some examples, like say a negative 5, and you substitute a negative 5 into this, you would get a negative 5 plus 5, which is 0. If you substitute a negative 4 in, because that is greater than or equal to a negative 5, a negative 4 plus 5 is 1. Substituting in a negative 3, a negative 3 plus 5 would be 2, and so on. And so therefore, to write it without an absolute value symbol, what plus 5 is going to get you 0? Well, it would be x plus 5. The absolute value symbols aren't going to do anything for this one because we're going greater than or equal to a negative 5. Because when this is x is a negative 5, you get 0, so we just have to leave it as x. Now then, simplifying exponents and radical expressions, that would be something along these lines here. This first one, this 2/3 has to be given to every single thing inside the parentheses. So we have a negative 64 to the 2/3, x cubed to the 2/3, over y to the 6th to the 2/3, and y to the 9th to the 2/3. Dealing with the number first, the cube root of 64 is 4, and 4 squared is 16. Now, a cube root of a negative 64 would be a negative 4, and then a negative 4 squared is a positive 16, so that's why it's positive 16. When you have a power to a power, you have to multiply the exponents, and 3 times 2/3 is the same as plain old 2, so it's x squared. Then y is 6 times 2/3, which is going to be y to the 4th. Oh, that's a z. Sorry. That should be a z right there. And then y to the 9th times 2/3 would be y to the 6th. Because 9 times 2 is 18, and 18 divided by 3 is 6. So our simplified form of that would be 16x squared, z to the 4th, y to the 6th. Moving on to the next one. Here we have 3u squared v to the 5th, w to the negative 4, over 2uv to the negative 3w squared to the 4th power. If you take and take the 4th power and the 3rd power of each of these things, 3 to the 3rd is 27. U squared cubed is u to the 6th. V to the 5th to the 3rd is v to the 15th. W is going to be to the negative 12th. Then in the denominator, 2 to the 4th is 16. U is going to be u to the 4th. V is going to be v to the negative 12. And w is going to be to the 8th. Simplifying and moving things around because you can't leave negative exponents in it. First off, nothing goes into 27 and 16, so that is just going to stay as is. Since there are 4 u's here, 4 of them can go away and you're left with u squared in the numerator. Here we have v to the negative 12, and because you have a negative exponent, that gets moved to the numerator, which there are already 15 there, so that's going to be v to the 27th. And then w's are going to, these are going to move to the denominator because of the negative exponent as well. So w to the 8th times w to the 12th is w to the 20th. And so that is our final answer. We can't do any more simplifying. So we would be done with it. And moving on to the next one. Third root of 8x to the 6th, y to the 5th, z to the 8th. Third root of 8 is 2. Third root of x to the 6th is x squared, because 6 divided by 3 is 2. Y to the 5th, and the third root of that, you can take 3 of them away, because 5 divided by 3 is 1, so there would be a y on the outside. And there's 2 left over, so the third root of y squared still stays underneath. And then z to the 8th, 8 thirds, is the same as 2 and 2 thirds. So therefore you would have z squared, representing that, and then there would still be a z squared underneath, because 8 divided by 3 is 2, with 2 left over. And so this would be how I'd want your final answer to be written. Simplifying this expression, x squared over 9y cubed root of it. Well, there is no cube root for x squared, so that's just got to stay as is. There is no cube root of 9y either. So now we have to multiply by a form of 1. In this case, it's going to be the cube root of something. And since we're just going to start with a variable. Since we have a y here, we need 2 more, so it's got to be y squared. Then 9 can be written as 3 times 3, which is the same as 3 squared. Since we have cube root, we need 3 of them total. We only have 2, so we have to multiply by 1 more 3. And then when you do that multiplying, you would get the cube root of 3x squared y squared. And our denominator would become 3y, because 9 times 3 is 27, and the cube root of 27 is 3. And y times y squared is y to the third, and the cube root of y to the third is y. This then would be our final answer. Our next example is the fifth root of x squared 9y. Same type of problem, except now it's fifth root, so we have to multiply by a form of 1 again. In this case, it's going to have to be a fifth root of something. Dealing with the y's, there's 1 here, we need 4 more, so it's going to be y to the 4th. There's 3 times 3, which we have 2 3's. We need to have 5 total, so we're going to multiply 3 to the 3rd on both the top and bottom. But this is just a form of 1, and so now multiplying it all out, you would get the fifth root of 3 to the 3rd is 27, x squared, and y to the 4th. Over, and the denominator now, 3 times 3 times 3 to the 3rd is going to be whatever, and the fifth root of that is just going to be 3. And y times y to the 4th is going to be whatever, and the fifth root of it is going to be y. And so this then becomes your final answer. Moving down to this last one, we have 2x squared over 25y cubed z, and it's the 4th root. So we can't factor anything out of any of it, so now we're going to have to multiply by a form of 1, and it's going to come in the 4th root of something. 25 is the same as 5 times 5, which we have 2 5's. We need 4th root, so we need 2 more, so 5 squared on both the top and bottom. Y cubed, we need 1 more, so we have to multiply both by y. And then z, we need to have 3 of them. And that will get us to our answer. Multiplying it out, 2 times 25 is 50, x squared, y z to the third. Fourth root of that. And then the denominator would become 5 yz. And then you would be done. So that's simplifying rational expressions. Then getting into adding, subtracting, and multiplying, dividing polynomials or algebraic expressions. When you're subtracting, you have to subtract like terms. So that would become a negative 2x squared. Then plus 3x. And a negative 6 minus a negative 5 is going to be the same as a negative 6 plus 5. So minus 1. Going and adding those things, you would have 4x squared plus 7x minus 11. Finally, with x plus 6 times 3x squared plus 2x minus 5, you have to distribute. And so that's going to be 3x to the third plus 2x squared minus 5x. And this will become 18x squared plus 12x plus 1. Then you can combine the like terms, which will leave you with 3x cubed plus 20x squared plus 7x minus 30. Where did I go wrong with that? Because I don't know how to multiply. That should have been a negative 30, because it's 6 times a negative 5, not 6 plus a negative 5. And so here's your final answer. Now, had you made that boneheaded mistake like I did and had a plus 1 here for both of those, it would be like a 4-point problem. You would lose 1 because of that. All right, then, moving on to factoring some expressions. First, both of them have integers, so we can divide a 2 out of them. This is r to the fourth, and that's r to the second, so we can take an r squared from them. And s cubed and s to the fifth means you can take an s cubed out of both. When you divide this one by 2r squared s cubed, you have an r squared left. And then it's minus an 8 divided by 2 is 4. R squareds are divided out, and you would have s squared. Then you're not done with this one yet, because you have two terms here, and both things are perfect squares, and so is that. And it has subtraction in between, so we have to factor it even more. So it becomes 2r squared s cubed, and then r minus 2s, and r plus 2s. If you only went this far, you would get half the points for it. And then the next one, because there's 4 terms, you're going to have to group things together. The way this one is written, you can do this a couple of different ways. Here, if you group these 2 together and those 2 together, perfect square, so that becomes x minus 7y and x plus 7y. And this one, if you take a negative 7 out, you would get x minus 7y, because a negative times a negative is a positive. And then, with this term and that term, you can divide out an x minus 7y, and you would be left with x plus 7y minus 7. And then finally, for this part of factoring, you'll have one where they're perfect cubes. And the rule for perfect cubes is you take the cube root of each thing first. So the cube root of x cubed is x. The cube root of 8 is 2, and the cube root of y to the 6th is y squared. The sign should be the same for that part. Then the other part has 3 terms to it. The first one is the first thing squared. The second term is these two things multiplied together with the opposite sign. So it would be plus 2xy squared. And the third thing is going to be that squared, which is going to be a plus 4y to the 4th. That is how you factor perfect cubes. Take the cube root of each thing, use the same sign, square the first term, multiply the two things together and use the opposite sign, and then square the last thing. Then operations with rational expressions. Here we're multiplying to dividing, so before we can do that we have to factor everything. Starting with this one here, to factor that, that would be x plus 1 times x plus 1. The denominator would be x plus 3 and x minus 3. And then we would have times, and this one here would be x plus 3, x plus 1. That would be x plus 1, x minus 1. And then times would get you, factoring that first, x plus 4, x minus 1. And the denominator would be x plus 4, x plus 1. And so now you can divide things out if possible. We have an x plus 3 and an x plus 3. We have an x plus 1 and an x plus 1. We have another x plus 1 and an x plus 1. We have an x minus 3, but none up there. And then we also have x minus 1, and the x plus 4s. And so we're left with x plus 1 over x minus 3. And then this other one encompasses all the different things that you could possibly have to do into one fine looking problem. So because we have a fraction within another fraction, we should mess with just the numerator and just the denominator first. This can be treated as one term, and it's over 1. So looking at the numerator, we do already have common denominators, so we just have to subtract, and it becomes x minus 4 over x plus 2. Dealing with the denominator, we have a common one that is going to be x plus 2. This has to be multiplied by x plus 2 to get there, so we have to multiply the numerator by the same thing. And x times x is x squared. X times 2 is 2x. Negative 3 times x is a negative 3x, and 2x and a negative 3x makes minus x. And a negative 3 times 2 is a negative 6. The other one we do not have to multiply by anything, so it's just minus 6. And so simplifying that, and then because you have a fraction divided by a fraction, that's the same as a fraction multiplied by another one. So x plus 2 times x plus 2 over, and this becomes x squared minus x minus 12. And is that factorable? I think it is. X minus 4, x plus 3. And so now before we multiply, we can divide out those things that are the same, which are the x plus 2's and the x minus 4's. So our final answer becomes 1 over x plus 3. Then finally, rationalizing the numerator or denominator. Here we're going to rationalize the denominator. So we have to multiply by a form of 1, and that form of 1 is the conjugate. Just change the sign in between. Leave the first term alone, and you're changing the sign of the denominator. So now when you multiply, denominators first. X times x is x squared. That's square root of 5x, negative square root of 5x, which go away, and then minus 5, because 5 times 5 is 25, and the square root of 25 is 5. Then the numerators, doing the same thing. X times x is x squared. That's going to be plus the square root of 5x. That's going to be plus the square root of 5x. And the square root of 5x times the square root of 5x is 2 square root of 5x. And then plus 5. And that would be your final answer because you can't factor anything out of it anymore. You can't divide this and that out of it, or that and that, because this is considered one thing and so is that. So that concludes our review for the Chapter 1 test. Good luck with it tomorrow.